Hey, hello, and welcome to the show. It's me, John Park. It's time for John Park's Workshop here on Adafruit Industries' global transmission networks and broadcasting system. I just made that up. And I want to say thanks for joining us over in the chats. I see we've got some people over in our YouTube chat. Hello, hello, as well as the, what's this thing called? Discord. If you want to join the Discord chat, and that's the place to be, especially if you're somewhere over on, I don't know, Twitch or Facebook or somewhere like that where there does not seem to be as much chat going on. There are probably people watching there, but the chat is probably happening here the most on our Discord. You can head on over to adafru.it/Discord and just look for the live broadcast chat channel. And that's where these good people are. Hello. So let's see what else is happening here today. We've got a coupon code for you for today if you want to save a little money on some stuff from the Adafruit store. I've also got a product pick of the week recap to show you. I've got a brand spanking new CircuitPython parsec to share. A little project update on the next iteration of Cat Meowzic synthesizer MIDI keyboard action. This was the first one. Who knows how deep this series will go, but this was the first one, and the guide is out for that one now. So you can go check out the guide on adding your own line out. I've got two of them on here. I got ambitious. I actually wanted some photos of using the 3.5 millimeter stereo out, so I added that, but there was my original 1/4 inch jack. So the guide is out if you want to go and do that. By the way, a thought I had, could be kind of a fun mod. I don't think I'll do this one, but a fun mod on these would be get yourself a $30 guitar pedal, one of these Donner brand or Amazon branded. Did you know Amazon makes guitar pedals? They're clones of a few common pedals. I think they have an overdrive and a fuzz and a distortion. They probably get a little more expensive as you get into reverb and things, but fuzz pedals are really cheap to make, so integrate one into this. That might be kind of fun. They just come in, they're those little slim kind of pedals. It might be fun to try to just add fuzz right to the thing and add your buttons and knobs right there and an LED. Integrated effects, why not, on the Cat piano. But I'm done with that one for now, but we'll be looking at the MIDI, a little update on the MIDI Meowzic that I'm adding the accelerometer to the ice cream cone. Spoiler alert, I got the ice cream cone open. It was not easy. You probably won't want to do it. But we'll look at it anyway. And I'll also give you a little intro and preview to an upcoming project, which is going to be a hexagonal beehive keypad kind of thing using low-profile Kale Chalk switches. So I've got some stuff to show you on that, and hopefully some PCBs coming in on Monday to start playing around with it. So we'll talk about that. Let's get into it. First of all, this is the Adafruit store. Just go to adafruit.com. It's the first page that'll come up. You can head on over there and look for fun, interesting stuff to get. And if you want to get yourself a nice discount, then just type in this coupon code on the way out. It is Toasty Toes, Toasty-Toes, and that will get you 10% off. It's good until midnight tonight, East Coast time. And that is my coupon code because I have a nice heated floor mat to put on my poured concrete floor here that keeps my toes warm. Even here in sunny California. It was raining earlier today. It's sunny again. The slab is so cold. Have I told you about this? I got like one of these rubber heated floor mats, and it's about a 20 or a 30 degree difference. I checked with like a little no contact thermometer. It just warms it up just in that one little spot. And no matter what HVAC you've got going, you're never going to warm up these concrete garage floors. So my toes were always cold. Now they are less cold. So Toasty Toes is the coupon code that will save you 10% today in the store. Let's see, what else have we got going on? The product pick of the week show, I do that one on Tuesdays. And I like to take a product, often a new product in the store, and give you a nice half off discount while I do a little 15-minute song and dance on it and show you how it works, do a little demo. This week's product pick was a really cool one, and boy, this one sold out quick. This was this reverse TFT feather, the ESP32S2. Let me give you a little recap. It is the ESP32S2 reverse TFT feather. This is the 240 megahertz Tensilica processor on here. We've got 4 megs of flash. We got 2 megs of PS RAM. This can do Wi-Fi, no Bluetooth, but this can do Wi-Fi, 2.4 gigahertz Wi-Fi. It has the native USB. It has a USB-C on it, which I love. One of the nicest features of it is this panel mount option that you've got. And you can see there's the 4 little mounting holes. So I've mounted it into a little case that I made. I cut this out of acrylic on a laser cutter. And it gives me a kind of a neat little way to very quickly add an ESP32S2 feather to a Eurorack project and mount it all in one. Here you can see it's just sort of a temporary solution here, and the jacks aren't connected up to anything. This is just sort of a proof of concept. It is the ESP32S2 reverse TFT feather. It just won't stop. By the way, I do want to say apologies for complaining about cold toes here in California, because I know there are some areas in the country and the world that are slightly colder than Los Angeles right now. So my apologies to anyone. Mike Billings says, you're in Michigan, huh? I bet you need to keep your toes warm in Michigan. Yeesh. Hope you're all doing okay with your ice storms and whatnot. Let's see what else. How about, let's dive into CircuitPython parsec. All right, let's get set up here. I'm just going to get my coding window up. All right. For today's CircuitPython parsec, I wanted to talk about unpacking tuples. So first of all, what's a tuple? A tuple is essentially a kind of list in CircuitPython, and it is a list of it's a variable essentially that can contain multiple entries in it. It's not the kind you make and change, but it's often the kind that your sensors are going to make and send you. So in this case, I have a magnetometer. It has this command. I can ask for the, what is it, the list2mdl.magnetic. If you ask for, hey, what's the value of that? What it returns is this tuple. So it contains multiple values. Sometimes I just want one of them. Let's say I have a little magnet here. I want to just be measuring the value on the y-axis of this thing. I don't need to get a bunch of different values to fuse. I just want to know one value. So I want to ask for, hey, not .magnetic, that's what the library tells me to say, but I want to say I just need to pluck one of those values out of there. I need to unpack this tuple and just get one of those values. So the way I'm doing it right now, you can see I'm saying magnetometer reading is equal to this list2 mdl.magnetic. That's returning a tuple with a length of 3. So I can say, hey, what's the length of this tuple? It tells me it's a length of 3. Okay, so I'm going to go ahead and comment that out. One way to ask for these individually would be this. I could say, okay, I'm going to make a variable called magx and say, give me the magnetometer reading in index 0 and another in index 1 and a third one in index 2. But in this case, I can cast them all at the same time, which is really convenient. Then you can do things with the different values that come back. So if you've ever seen this kind of notation before, it's actually 3 variables, magx, mag y, mag z, those could be any variable names, is equal to, and then I say whatever that tuple is. So that tuple returns those 3 values and casts them into the 3 variables. So now if I go ahead and rerun this code, let's see, I've broken something. Magnetometer. Oh, let me just ask for it right here. There we go. Okay, so now you can see I'm casting the magx, mag-y, and mag-z as the 3 values that come back from unpacking this tuple, which is the list2 mdl.magnetic. Now I'm just dealing with one of those by name. I'm saying, hey, go ahead and just print the mag-y. And so now you can see if I take my magnet and start hovering that over this little magnetometer here, I can reverse that and get those values to increase and decrease as I move that around. So that is how you can unpack a tuple inside of CircuitPython. And that is your CircuitPython parsec. All right, so, and hey, hello, I just saw a couple other people join up in the chat. Hey, DJ Devon 3, good afternoon, thanks for joining us. Okay, so let's see, before I forget, because sometimes I mean to do these multiple times in the show, I forget, I will say again, our coupon code today, if you want to get 10% off, actually I know DJ Devon 3 is a good proponent of saying, hey, you can find these coupon codes throughout the week, so don't panic if you miss one. Here's the one for today for my show. It's 10% off. Just type in toasty-toes, toasty toes, and that'll get you 10% off over in the store. Actually, the next thing I want to do is actually take a quick look at the new guide. So I mentioned the Meowzic cat piano. So this guide came out. And it's actually a pretty quick and easy one because we're not doing any microcontroller stuff. There's no code. 2-page guide, so I've just got a little image of the finished guy there running the Meowzic into a guitar pedal and into an amp. And then I list out the parts that you need. You've got options here, by the way. I used, as you saw before, both a 1/4-inch mono jack as well as an 1/8 inch or 3.5 millimeter stereo jack in mine. The stereo jack is helpful if you're going out to little like stereo Bluetooth speakers that have an aux in, that kind of thing. Those will only come out of one speaker if you use a mono jack like the second one I have listed here. So internally I just shorted the tip and sleeve, or rather the tip and ring, essentially left and right connections inside of that. It's got 3 tabs on it, so one's ground and the other 2 are sharing my audio output from the Meowzic. The rest of the parts there, you can pick those up, just make a decision between those 2, or get yourself a 1/4-inch jack. We don't sell any of those, so you can go find one. I actually have a link here to, I think in the build page, which is the only other page, I have a link to the place where I got both the foot switch, pedal switch that I'm using, stomp switch, as well as the Switchcraft, really nice open frame 1/4-inch jack. Those are from Love My Switches, which is a nice resource for guitar pedal builders, but also for people doing other electronics stuff. So guide, I've got a nice little fritzing chart here, diagram here, as well as the schematic with a little imaginary part there for the Meowzic's audio out, so I could connect it to something. The removal of all 21 screws. You've seen me do this on air before a couple times now, I think. And then identifying the audio out you'll need to find the ground, which there's ground lines in various places. The easiest one I found was the center common pin on the on-off switch on the piano. And then the speaker connection where the audio line goes in is where you'll be splicing in basically the rest of the circuit. There's a few sub-assemblies to build here. I think I pre-made these on the show, so you didn't see me put these together, but I like to make these little assemblies with easy connections until I'm ready to finally solder stuff down. In this case, most of it I just left as these easy connections that actually ended up working out. At one point, I thought I had a noisy connection. It turned out I had a bad potentiometer, so I actually ditched that one. There was just a pot that somehow had gotten really noisy and crunchy, so I ditched that one. But using the DuPont connectors worked out fine for these connections. And there's the little circuit being put together on our little Mint Tin Perma-Proto. Nice size board for this type of build. You don't have to use it. You could go sort of dead bug or air wiring things if you want. But in this case, I went and put it on a little Perma-Proto. Some little indications of how I drilled those out. You can get stepped drill bits, or you can just work your way through progressively. A couple sizes. In soft plastic, you can usually just do a pilot hole and then your final hole, unless it's one of those really large stomp switches. That's fairly big. I think it's like a 1/4 inch. Something like this, a little tapered reamer, is great to have. I don't know where I got this. I've had it for years, and I also put a ton of screw on it at one point to make it a little, I don't know what I was reaming that required that much force, but it is nice. But these are great. It's essentially, I think, 5 or 6 blades running around this way, and you can tape off or just place your finger at the diameter you want to go to and just work your way in. And that's actually what I used for most of those holes on there. And you've also got choices, since we don't carry those stomp switches, and those stomp switches are overkill because it's actually 3 position, or rather 3 poles of dual position. I just put in the guide one of our typical toggle switches, single pole, dual throw. There's the addition of both my 1/4 inch and then later that 3.5 millimeter. For these potentiometers, let me see if I can grab one. These usually will have a registration tab on them to prevent them from spinning around. So since what you do with the potentiometer is turn it, just gripping the shaft with a nut and maybe a couple washers usually isn't enough. So you'll see there they have those. Let me switch to a down view. Nope. There it is. Boy, this is very, sorry, this is very, very warm exposure or color balance today. There we go. That's a little normaler looking. You can see here this little tab on the pot. Sometimes you'll see build instructions that say, oh, just go ahead and snap that off, which is fine in some cases, if especially your pot is mounted in something like a PCB. But in this case, it's just wires running off of it, and so the danger is that the whole thing gets loose pretty easily. So don't snap that off. Just make a hole for it. What I did was I first made the hole for the pot shaft and threading there, and then just lined that up, put that into the outside of the case, and made a little mark next to this. Actually just scored up the paint. The Meowzic exterior has some paint on it. So I knew where to drill a little second hole, tiny little hole in there, so that you can feed that in, and it'll prevent that from spinning around in there. So you don't really want to snap those off if you don't have to. Let's see. You can see it actually in this image right here. That's the little hole. I don't know if I ever cleaned that up. I think I did. There was a little bit of sort of chipping of the paint when I poked the hole in from the inside out. That's the downside. You will see that little hole. Maybe you could paint over that if you wanted to. Fill it with some putty. And then put that all back together. Hopefully those images will be clear enough for people who want to make the mod. And then I got a little demo there. So that's the little recap of the Learn guide there. And I would love to see people do some of their own mods. And like I said, there's more you could do with it. It'd be really, really fun to integrate super cheap effect pedal or two inside of there. So the thing has effects built right into the cat piano, and then you just plug it into whatever output you're using. All right, let's see. So next up, speaking of cat pianos, so last week I got into adding an accelerometer so that we can adjust either a pitch bend or some other CC value with that little ice cream cone. So I wanted to show you, got the ice cream cone open. Let me make this window a little smaller and run over there and show you. The next step is wiring and integrating that accelerometer into the whole retraction mechanism. So get over here. Oh wow, that is really, did that camera get bumped or zoomed? It's really missing the top of the head. Oh, there it is. All right, it just got that window got very big. All right, 1 second. Tell this not to shut off so I can see the chat. There we go. So, first of all, ice cream cone. If we look at, this is the one from the line out mod one. As you can see, there's a little retraction lock there. This is on a little spring-loaded reel, like similar to a retractable keys, dog leash, tape measure. So this is on the wire, which has 2 lines running up to a little microphone in there. And this little microphone is essentially glued shut. There's a dome on the top, and then there's 2 halves here. So these are not easy to get open. Odds of doing it without just totally ruining it are fairly low. Oh, geez, sorry, I never pushed the fix to the camera positioning. Hold on 1 second. Hey, there we go. So, yeah, I'm still slightly decapitated, huh? Hold on. Getting there. Let me zoom that camera out just a little bit, sorry. That's the wrong way. That's better. Okay. So odds of getting these apart, kind of low. What I did was I went in, so this is what it looked like to start with. I first used a little metal sort of spudger tool, both a really thin sort of flexible one and then a slightly thicker one. You can see these are actually from one of these iFixit kits. I think this is one that Adafruit sells. I have a couple of these in my shops. So I went through here and I could feel that I was essentially breaking the seal of a little bit of glue and paint probably around there. This is a painted bit here. It's actually funny, by the way, now that I've started to get very familiar with these Meowzics, if you look online, you'll see a couple of different minor color differences in some of the buttons on different models, and also this cone is painted in some versions. There's all of these little molded details in here. I don't know how well you can see those. There's like little molded details in here. You can't see them much, right? In some versions of this, those are painted up in darker colors as well. So anyway, I went through, broke that seal a little bit, then got in there and really carefully, you could see a seam line in the ring here and a little bit in the orange part. I actually went through with a X-Acto, mounted this thing so it wouldn't slip and I wouldn't cut my hand open, and just very slowly worked my way through getting down in. Then I went in with a chisel just so I could get a little bit of force on that. Eventually I could tell I had that mostly open, but there were pegs in there that I had to cut. They actually cut with the X-Acto blade, 2 of them, one on each side. Got it open far enough to pull the dome off, then I could see inside. So these 2 pegs are what got cut. The one on the bottom I didn't have to. I was able to kind of wiggle that one out. So I don't know if these ones were glued in there. I think they were. There was also one little drop of glue there. Anyway, you might ignore this entirely and just forego this, 3D print this thing, drill some holes into it. I don't know, but I did manage to get one open fairly in fairly good shape. So what was in there? This little microphone, which has a little rubber, like elastomer, shock casing around it. That was shoved up into the ice cream scoop there like that, and then this little bracket held that in place. So I unscrewed that, pulled that out. This ended up breaking this a little bit. This is the cable it was on. So one end here was soldered into the board there. I just desoldered that, pulled that off. The reason this is kind of snapped up here is that there was a nice little strain relief that I was trying to see if I could yank the wire through, but I think it got molded in place. So this just kind of popped off when I pulled hard enough. I was hoping to reuse this. Maybe I could. I'd probably slice this in half and reuse that, which goes at the base here, I believe, like this, to give really good, like way heavy engineering here to keep kids from breaking it. Strain relief on the mic wire. So that's kind of a goner, maybe reusable. The mechanism that it winds into, so wire goes through this little cone holder here. This little hole at the bottom of that. So cone is all the way, I've got these backwards, but all the way to end. So that gets, when it gets retracted, cone will sit there like that. And then this is the spool that the wire gets wound around. Has this spring that you would twist a few turns before setting it in place there, and that's what gives it the retraction. Pulls that out as you grab it. It stayed pretty intact, so that shouldn't be too bad, and it's got a nice little post molded into the base here that this fits over. There's the little retraction button, lives in there like that, and that pushes against this little hinged release that allows, that's what this is locking against, that allows this to fly forward again. And then there's a little cover for the whole thing that'll sit on top of it one way or another. So what I wanted to do is figure out, could I make a cable that'll work well for my accelerometer. So there's my STEMMA QT accelerometer, and it's what, the MSA 311. So this is running over I2C. We've got pins on there you can solder to. We also have stemma QT ports on there. So I figured up here in the ice cream cone end of things, I can probably mount this right inside of the cone, just using one screw. It'll stay in there, and that means we'll get a fairly consistent, this isn't going to be flopping around in there, we'll get a fairly consistent orientation for that, which will be kind of nice. You have to find certain pitches for it, but tilting it, we can probably get a consistent orientation. I will probably feed this through and maybe tie a little knot or use a zip tie for some strain relief here, or maybe I'll find a way to reuse this nice little guy here. And then on the other end, what I did was I soldered a stemma QT, sort of half of a stemma QT cable, so that can just plug into the board. And that's just nicer when assembling something like this that's going to get fed through some things, to not have to solder it in place. So what I used here was some RJ-14 wire, and I've lost the ends to it, but this is essentially 2-line telephone cable. So there's a few different specifications for these. There's like, I think the RJ-11 is the 2-line. RJ-9 might be the handset line, which has actually a smaller connector on it, modular phone connector on it. But this is, I believe, the RJ-14. Someone tell me if I'm wrong. I always get some of these mixed up. But this is meant for 2 phone lines, essentially. When you had 2 different lines in your house, it was often running over this. And so this could go from the wall to the phone, and then the phone could have a button for picking line A and line B. So 4 conductors. Snipped the ends off. Turns out this was some really nice stranded copper wire per connection. So if you look at these here, these are some nice stranded copper wire, not that nonsense kind of foily stuff you sometimes find in these. Not twisted pairs either. So this has the potential to work well for I2C. I was a little concerned that this is a pretty long run. This is about 3 feet I chopped off here, which is actually longer than I think the microphone started with by maybe a foot. So this is a little excessively long, but I figured, yeah, let's just try that. I can cut and resolder this end pretty easily. And then I'll be able to have, I kind of need a little bit of a longer run because I'm going to be mounting the KB2040 that's doing all of the reading of the keyboard matrix and sending out the MIDI and all that good stuff. That's going to be mounted up in here where there's a nice space, I think. So I needed this extra bit of run because normally the mic just goes right here. So otherwise that may, we'll see, that may spool nicely around this. This is a bit thicker wire, so I could end up being in trouble with that. We'll see once I put that together how that works, but it would be cool. If not, I will bail and I'll just have, you know, a short little slack run that can come out. I don't necessarily need the mechanism there. So let's test this out. This is, I was originally running over one of these nice 400 millimeter long. It's the longest ones we have. This could be too long of a run for I2C, and then what you can do is start lowering the frequency of the I2C channel. It's a fairly simple command when you're setting up the I2C device to say, hey, let's just use this at a lower data rate, and then we can get accurate reads again. And let me just switch back over to this camera view here. Put that little down view. Oh yeah, some of these got real big. There we go. Put it off to the side there. And put this in frame. So what we'll do actually, let's bring up, I'm going to plug this in. I should be able to put a little print statement in or just look at a MIDI output viewer. and see what kind of info we get. Yeah, in fact, let's do that. So what I'll do, let me just open up MIDI monitor. And I'll add a little window of that here. And 1 second. Let's see, what view can that go in? Right here? Yeah. So let me do a screen capture. Always tempting fate to add screens to this while it's running, but knock wood. I've got another one I got to add later too, also for the keyboard project. So this will be tempting fate here today. Let's change that from a monitor to a window. Thank you, DJ Devon 3 looked it up. It is RJ-14 for the 4-wire, 4-conductor telephone cable. Okay, so what you'll see there is the MIDI output of my KB2040. So I'm reading the accelerometer data of this board, and then I'm unpacking a tuple, and I'm just grabbing one axis of it, and then I'm mapping that to be a range of 0 to 127 of these MIDI CC values. So if you look at, I'm going to go ahead and clear. Oh, that's huge right now, but you know what? I'll leave that huge for a second. So you should see that's living at about 64, and then as I tilt it, go down to 0, up to 127. What am I rolling this here? Yeah. Okay, so let me push this view just so you can see both at the same time. So, oh man, that thing got weird resolution-wise. Let me try to make the software happier. Hold on. That's better. Okay, yeah. So you can see here, running over like 3 feet of telephone cable, and it looks good. It looks stable. You can see here if I just rest it, it's just staying at 74. Let me try to get it totally flat. There we go, 64, right? So just sitting there on its own, it doesn't seem noisy. It seems responsive. Let's see if we can, I'll tempt fate further. Let me open up a piece of MIDI software. I'll close that window, actually. Let me take that off of there. I'll just run Helm, free open source software. Let me pick a lead keyboard sound here. Monster lead, what does that sound like? Okay. That's great. That's good enough for what I'm doing. So getting the long length of cable there, still I2C was happy enough with this in this case. Not always the case, but worked well. Didn't have to change the frequency of the I2C or any of that stuff. So okay, so Todd's saying you shouldn't see noise on the data from a long I2C run. Just the bus will hang and your sketch will halt. Well, that's no good. Okay, so I will do a lot of testing before I publish this, but if I need to, I can drop the frequency of the bus and hopefully prevent that. I think we also may still have, there was a Adafruit product that was a I2C terminator, which helped with long runs, but it's looking like I won't need that. In fact, let me show you the just because I'm having fun tempting fate here, I'm going to add this, I'm going to switch this window over from just being the MIDI data to being the Helm software view because it has a nice visualizer of the filter that I was adjusting there. So I think it won't update super fast for the broadcast, but if you see that peak, a little mountain peak looking thing, that's it's actually very responsive here, but the frame rate isn't gonna be great in broadcast. But so that's what that accelerometer data is being mapped to right there. DJ Devon 3 said, I think the Terminator was for Ethernet. No, I think it's just a general purpose I2C Terminator. I demoed it using Ethernet jacks, but you could, I don't think that was a requirement. That was just if you wanted to use a longer cable, you could add that Terminator. Another suggestion, C. Grover says a shielded 4-conductor USB cable may work as well. Yeah, that would be a neat one to try. There's some nice thin flexy ones that might be more flexible than this this PVC coated phone cable here. All right, yeah, so that's what's going on with that. Just wanted to give you an update on where that build is going. That'll be the last thing I'm adding, I promise. So I've got reading the keys, reading all the buttons except for the volume and tempo buttons that are built onto the bottom. I may look and see if I can scrape some traces and steal those as well. I've got a 3.5 millimeter TRS MIDI output, and then we can also do USB. Yeah, over in our Discord, by the way, thanks, Todd posted, there's a link to that active Terminator extender thing I was talking about. And with that, I did, I think, a 50-foot run of, or 100-foot run of Ethernet cable, Cat5 cable or something like that, and had success with I2C over a very, very, very long run, out of spec run of wire. Let's see. Oh, hey, Pixel over in YouTube says, if Adafruit could do free shipping instead of 10% off, that would be awesome. We do actually have some free shipping I think we have some free things at different order sizes. I think these are the ones that are still in effect. If you head over to, let's go to the main site here. If I can find you, where'd you go? Is that you? If you go to adafruit.com/free, not fee, free, you'll see the deals and more. So $99 or more in your order, you get a free Perma Proto half-size breadboard. For $149 or more, you get a KB2040. $200 or more, you get the free shipping if you're in the US. And then $299 or more, you get a free BBC Microbit V2. These stack, so you'll get all of them if you get the top one. And there's a question here about it. How many do I get? You get them all. So if you spend $200 or more and you're in the continental US, you can get the free UPS ground shipping and the KB2040 and the Perma Proto breadboard. And I believe you can still stack this 10% off. I don't know where the freebies happen before or after the coupon, honestly. So that's maybe that's answered in the questions in here, but I'm not sure about that one. So let's see. So next up, I wanted to talk about upcoming project, and for that I want to show you. I'll go back to the down shooter here. And so key switches, right? We're all familiar with these nice Cherry MX style. These are actually Kale box whites that I have here. But these are keyboard key switches, mechanical key switches. We have linear, we have clicky, we have tactile. And that size of key switch is great for certain things. It's also kind of honkin' huge for other things if you're trying to do low profile keyboard things, low profile sequencer things, button input, numpad, calculator, what have you. So there are a couple different manufacturers who make some pretty nice low profile key switches. And one that I really like that we have here is this Kale Chalk. C-H-O-C, like chocolate, I think. I don't know why they call it that, but there you go. So Kale Chalk, first of all, I'm gonna try to focus this and boost that exposure a lot. There we go. Try to focus that a little better too. That's good. So you can see here it has some similarities and some differences. First of all, just the footprint of it is pretty similar size, which means you can have a very similar typing experience on it as far as the size of the keycaps and the distance between keys, which is great. So this is good for making something that sort of lives in a place somewhere between a sort of laptop keyboard and a full-size mechanical keyboard. However, the profile of it is quite a bit lower. So you can see these both sit there on the board. That's the base of them. And the chalk casing, if I press the switches down, is, I don't know, roughly half the height, something like that. Maybe a little smaller even, of the Cherry MX. And so we've carried these in the store for a little while. They look pretty similar on the bottom too, right? But they are not compatible. So you can see here the pins are in different places. There are some registration posts that I think are standard on chalk that are maybe optional on Cherry MX or not even there at all. So you get these 3 registration posts on the chalk there, so you've got to account for those. And then we just have essentially completely different placement of the switch pins there. So up until now, we have not had a nice, easy way to use these. So I went and built a footprint for these in fritzing so that I can make some PCBs. I can share the footprint for people who want to make their own PCBs. We'll probably end up making some stuff with these eventually. But I wanted to try to build a little hexagonal sort of beehive themed keypad, a little 7-key keypad. So let me show you I'm going to bring up fritzing here. And I'll have to add a window, so please bear with me for a second. And I'll show you what the footprint, kind of what that entails, making the footprint a little bit. I'm not going to go into great detail here. As well as putting together a PCB using that. So I will load up this fritzing document here. And that's probably a good size. So let me add a new screen capture. And I'll show you there was an inspiration for this, which was a hexagonal key switch that was part of a keyboard as well as like a device that looks really cool to have hex-shaped keypads. So I'll show you that too. Let me just fix this window that's become a black hole. And we'll open that fritzing window. There we go, B-board. And I'll make that a little smaller. And I'll make my view a little smaller here, off to the side. Okay, so you can see there's a few steps involved here. So first of all, Lamore asked me if I could make this with underlit neopixels underneath the keys. And if you look again actually for a moment at the key switch, you'll see there's a window molded into the bottom. So that's designed to have a little underlit neopixel coming through and then shining under your keycap. Similar to, you can see on this Cherry MX, there's also a little window, so that's a kind of a standard thing in these. By the way, you'll also notice it's a completely different stem. So you cannot use Cherry MX style keycaps that have that little sort of cross shape in them. They instead have this little robot face, 2-prong electrical outlet looking tooth thing design. So it's a completely different style of keycap that'll fit onto that. So you can see one of the things involved here was I made a little breadboard icon. Sorry, a bunch of this is not routed here, so it's kind of a mess of wires. But so in fritzing, you have these three views. You've got your breadboard view, you've got your schematic view, and you have the PCB view. So I've made a little breadboard view, and I have these two sort of coming off to the side so you can see what you would connect to. Then I have a, if I zoom in on just one of these, I have a schematic. These, by the way, I'm going to fix these up. There's a really great fritzing forum user named Van Epp who I asked some questions, sent the part, and they made some suggestions and fixes to get things onto the grid. I had not built the schematic parts on the grid and did some other weird things. So I'll hopefully be using or modifying that version he sent to fix mine up. And then there's the PCB view of this. So what I'm going to do, let me turn off pretty much everything and then try to just turn on my parts here. Okay, so where part and let's see. And silkscreen top. Okay. That's a little easier to see. So this part now has a few things going on. These are measured based off of the data sheet. They have, you can kind of ignore this green and now blue sort of connection here. That's not real. That's just an artifact of fritzing not liking my having a through-hole part and a SMD part kind of combined into one. But these three yellow circles in the middle, those are going to be drill holes that will just allow those plastic pegs to set on. The circle up here is the hole for the reverse mount NeoPixel, which even though it is rectangular, it's a pain in the neck to make a cutout in a part that is rectangular. It's also more likely to get weird when it gets sent off to the board house. So I think I've made a hole, it's 4mm hole. I think it's big enough to clear everything and still allow the part to be soldered down. And then what you're not seeing is the pads, which are actually on the bottom. So if I look at, that's adding the bottom layer. So those are the 4 pads for the NeoPixel. So the NeoPixel has data in, data out, current voltage in, and ground. So I have those 4 parts on the bottom side of the board, and then I have these through-hole pads for the legs of the switch on the top and bottom side of the board, since they're through-hole. So that's what the part looks like in close-up. This is the idea for the board here. Sorry, zooming is being very slow in fritzing. So let me turn on, let's see, I'll leave that off. The traces, I needed a couple of vias to get underneath, some overlaps, and there's the ground fill copper layer on the bottom. But essentially it's going to look like that. I have I sent off to JLC PCB to get a set of 5 of these made, and they're supposed to come on Monday, so cross fingers they'll work. If anyone sees some obvious problems, let me know, but I'll also be testing these out on Monday. DJ Devon 3 asks, does this design use the LED as the diode for a diode matrix? It does not, no. I'm just using, I have a cutie pie mounted on the bottom. That's what these holes are here, and I've put it at like a 30-degree angle to kind of match the hexagon. It has enough I/O for me to just do direct 7 GPIO switches, and then 1 data line for the NeoPixels that'll be underneath those there. So no diode matrix necessary for this one, but you could do a diode matrix and make a huge board out of these. So the other thing I want to show you is the incredibly cool keycaps that were the inspiration for the whole thing. Let me grab one other window here and show you how this whole thing started. let's see, let me go here. Open up this window here. So this is a MIDI controller. The same builder also makes a macro pad similar to what I want to make. They made it with, I think, 9 switches, and kind of this hive shape almost. So what I wanted to do is just make a 7 key, like you saw my design there, so 7 keys sitting inside of, nesting nicely inside of each other. But these keycaps are gorgeous. So look, you get this nice, beautiful design. I'll have, you can see actually there's underlit NeoPixels under those, and I'm guessing they're going to look pretty similar in mine because of where they lie on the chalk switch there. This builder also created, their name is Sol, S-O-L is their online handle. They're a designer and creative technologist living in Milan. They made these keycaps, had them manufactured and for sale. I got a couple packs of them. They turned out to be like the last 2 packs I could find anywhere on the internet, but Noe is going to, actually already has modeled a 3D model that's very similar that'll work for anyone who wants to print their own or do them in different colors or can't find these. They'll probably come back in stock. But so that's going to be, was that a 12 key? Thank you for counting properly. I didn't I didn't look at it closely. So yeah, so mine, you can just imagine a little 7 key section, a little hexagonal section of that is what I'll be building. And then you could use it for anything. You could use it for, the idea behind this one, I'm pretty sure, is to do an isomorphic keyboard, which is a term in music keyboards where there is a very different relationship between notes than the typical semitones of a piano keyboard. And instead you can do things like have only sort of complementary notes next to each other and you know, minor versions heading this way and major versions heading that way. I don't know a lot about them, but I've played around with like iPad versions of them over the years. So I think that's what the idea for this designer was to do a MIDI controller that has this sort of unusual non-piano style layout. Mine we can kind of do anything with. It'll be USB HID and HID MIDI possible with it. So we're excited to be getting that going. Once I get boards in, I'll put those together. I'll probably show you a build of them if they work, or if I can bodge them enough for them to work next week. And then kind of flesh out a bit more of a design. And the Ruiz brothers are going to work on keycaps and some case stuff for it as well. So we should have a cool collaboration on these hex keypads, hex pads. That actually have 7, but anyway, that's what that's looking like right there so far. I may share some tips on the fritzing side of things. I can't remember if I've shown part making. I did actually. Let's go and look. Let's go learn. I need to remind myself. Did I show how? I think I just showed how to make a PCB. Let's see. What was that project called? The Pico MIDI, modal MIDI keyboard. Whoa, not found. Let me reload that. I don't believe you. Modal MIDI. It's gone? Why is it gone? If you search a name, click a name, go to view all, and let's see if this is a alternate route to finding the thing. There it is. I can see it. Please be there. Yay, it's there. All right, where is it? I Sure thought I showed how to build this. Am I thinking of a different guide? I really swear I had a huge section on... Oh, wait. Is this it? Oh, I have to go through this guide. Sorry. Ah, 21 key Pico keyboard. It was similar, but not the same. Okay, here's the one. So making a custom PCB with fritzing. So if you look up this one, DIY Pico mechanical keyboard, this will show you how to get... yeah, I had built a part, but I didn't show you how to build the part, did I? Yeah, we're just importing the part here. Yeah, so I may, if people are interested, I may do a little write-up on building that part or another part from scratch. It is a complicated part. I may simplify it and just do the switch. Adding the LED may be a bad idea. I'm still out on that because there is no one part you can buy that has that integrated, so it may be better for me to just put them at a proper offset in their origins so that you can snap them both to a coarse grid and they'll be in the right spot for each other. That may be the better way to go because fritzing really doesn't like me trying to have that bottom pads and top part based on how it's built. But it's kind of cool because the fritzing part is essentially just an SVG, and you can build it based on naming and hierarchies of the SVG file, which you can do in Inkscape or in Illustrator or just by straight editing the SVG file. And depending on naming and hierarchy, a lot of the work gets done for you by fritzing. There's also a parts editor in fritzing that works really well for certain things. It kind of fell apart once I tried to get very complicated with this, this mashed up part. But yeah, let me know if people are interested in seeing that. I know KiCad is very popular, EagleCAD, but you can also do these things in fritzing, which is kind of cool. All right. So that is going to cover it. That is what I'm up to. Thanks everyone for stopping by. One last time I'll say, if you want to get 10% off in the store today, type in Toasty Toes, Toasty-Toes, in the coupon code on your way out. And you'll get 10% off on your order. All right. Thank you everyone for hanging out. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. And look, there's Lars.